This is Amateur Logic 72 for November 15th, 2014. TNC Pi, Wattmeters, and Python. This episode of Amateur Logic is brought to you by Gigaparts.com. Use the coupon code ALTV-HEIL by December 31st, 2014 and save $10 off any color of new Heil Pro 7 headset. MFJ, the world leaders in ham radio accessories at MFJenterprises.com. And by ICOM. Get on HF with ICOM. Hi, welcome to Amateur Logic episode 72. I'm George.
I'm Tommy.
And I'm Peter.
And we've got a fun show lined up for you today. A few different type of things in here, but that's just the way it's going to be this time.
It's a variety show.
Yeah. The neighbor out here is mowing his yard. You may can hear that.
At least the weather dogs aren't fired up.
Yeah, that's true, but they could be before the show's over. So, Tommy, what have you been up to lately?
Man, I've been playing around. Well, actually, I came over here and I hijacked that TNC Pi that you made a while back.
Yeah,
it's been sitting on the shelf, and played around with that this month.
Yeah, I did. Well, I took a look at some test equipment that we kind of all need one of these. Pretty handy little thing to have. But Peter, what have you been up to?
Well, I put together a bit of video about a programming language I use called Python, which I really strongly recommend that people check out because it's so easy to learn.
Yeah. I haven't really even looked at Python, I don't think.
Really? Yeah, it's nice. It's a nice little scripting language.
Similar to C?
No, not at all.
Really? Okay.
Yeah.
Well.
Did you ever program in BASIC, George?
Oh, yeah.
Yeah, it's a bit like that on steroids. No line numbers, though.
Yeah, but the indentations and things in the code are kind of funny. It's
oh, yeah.
Really?
Yeah.
That's just a peculiarity of the language.
Absolutely.
Wow. Well, I'll be doing some sooner or later, I'm sure, if I want to do anything on a Raspberry Pi, although you can get C for that, can't you?
Sure. Oh, yeah. You can do. There's a lot of things you can program on it.
I guess you can get BASIC for it, too.
I'm sure you can. Basic, PHP, Mono.
Yeah.
I installed Mono on mine, playing around with some of the .NET type stuff. C#.
Yeah. Well, cool. Well, let's get on into it. Peter, what is your first email down there this time around?
Yeah, my first email is about my balloon transmitter segment. Now, perhaps some people were expecting to see the balloon floating this particular month, but I still have one or two little tests that I have to do before I actually put it up in the air. I want to see that signal is actually going to be received over a few kilometres first. Anyway, Dave, Victor Echo 3 Oscar, it's either a 1 or an India, probably in India, says he is, so he's obviously a Canadian, says he's been doing something similar with high-power rockets. He used a PC controller to control the AD9850 board. He says that you need to be aware of harmonics and key clicks from keying the carrier. He suggests using a FET to get the power up to 1 watt. He also provides a link to www.handsummoners.com/ultimate3.html, which is apparently quite useful in that regard. Now, with respect to getting the power up to 1 watt, I think, I'm trying to remember for the particular frequency I'm using, I think I've got it's either a 50 or 100 milliwatt limit. So having that power amplification circuit isn't of much use. However, having a filter on the end is a good idea, and so I'll check the link out and see if I can add a few extra components in there.
Cool, that's a good tip there.
Absolutely.
So what have you got? You got that 3-page email over there, don't you?
Yeah, I've got a long one. I'm going to kind of summarize mine a little bit because we're going to run out of tape on the camera otherwise. But
Okay.
actually, it was a good email from Lou, KI6YVX. If you remember on the Pacificon episode, George showed these, we're on camera, sorry. These little 2 devices that he got out there at Pacificon. And,
No, actually, those were mailed to me afterwards.
Oh, okay. My bad. Anyway, they're pretty cool little devices. But anyway, he says, I watched Pacificon special today and saw George discussing the Power Pole PAL and the Power Pole bass backwards.
Yeah, that's the PAL right there.
Yeah.
And that's
the
back
bass,
backwards.
that's the bass backwards.
Something like that.
Okay. Anyway, he said he showed a shot of the FAME website. FAME is Fresno Area Mentors and Elmers. It's a local instructor group that he belongs to, but it's not really associated with the Power Pole tools here. But said they have a small group of hams, 3 guys who like to build, make, etc. We host a maker table at local ham fest and get-togethers to promote kit building, developing, ham-related projects, etc. We use Arduinos, Raspberry Pis, as well as simpler projects. Our mantra is, wouldn't it be cool if? Yeah, that is a good mantra. So that kind of lets your mind run wild on things that you can put together. But anyway, we don't mind taking someone's project and taking it to the next level. But these 2 are some of their most well-received devices that they've done. He says, I enjoy Amateur Logic and eagerly await each show. Keep up your great work. 73.
Yeah, well, thanks, Lou. That's I'm sorry about that. Actually, apparently you didn't see the live stream because when we did the live stream, I said it came from the Mount Diablo Amateur Radio Club.
Oops.
And then I realized that wasn't right, and I knew Gordo had said something about it on a previous episode of Ham Nation, and he mentioned FAME. So that's why I put that on there. But good to know the real truth on it, because I didn't know when I was editing. The card that came with it told what they were, but it didn't say who they were from.
Yeah.
So I got it.
I still think they're pretty awesome little devices.
Oh yeah, very handy to have in your bag of power poles. You know, I keep a bag of power poles here, and those you keep a bag of PL259. Yeah.
We all have our baggage.
Yeah. These stay with my power pole, so I got them whenever that issue comes up. Well, Peter, I know you've already told us what you're going to do this month, so anything else you want to say before we look at it?
There might be a few viewers out there, perhaps, who are more just traditionally into ham radio and not so much into the computing side of things, and have looked at programming and thought, it's all too hard, I'll never learn. But look, do have a look at Python. It's a really simple language to learn, and the commands are very much just like English. So with just a little bit of effort, a bit of practice, you can pick it up quite easily. Today we're going to have a look at a programming language called Python. But first, a little history. In secondary college in the early 1980s, I studied a programming language called BASIC on an Apple II computer. BASIC was an extraordinarily easy language to learn with simple, powerful commands using a simple English syntax. For example, let's say you wanted to write a program to print the words C++ is completely incomprehensible. You would first give the command a line number, say 10, and then use the print statement followed by the sentence which is contained in exclamation marks. 10, C++ is completely incomprehensible. You would then run the program, which means that you would tell the computer to start executing the commands in the program. BASIC was simple, powerful and readable, but admittedly ran slowly on older machines like the Apple II. It was no surprise then that shortly afterwards that the fun police arrived and decreed that BASIC was bad. They said that having line numbers was bad, that it wasn't a structured language, and that it encouraged poor programming habits. So people moved away from using BASIC towards structured languages like C, C++, and Visual Basic, which could run much faster but were arguably less readable. Around this time, I lost interest in programming, and I was not to return to it until some decades later. In 2012, however, I faced a problem. I was earnestly trying to find a comet using images from the SOHO telescope, and I thought it would be helpful if I could write a program to find comets by mathematically analysing the data stored in the image frames provided by the telescope. I searched the internet and found an implementation of BASIC called Just BASIC. By now, computing speeds had increased by a factor of several magnitudes, so now BASIC programs could run much more quickly. The syntax and structure of Just BASIC was virtually identical to Apple BASIC, so it didn't take very long to master the language. However, my finished program was still a little slow, so I thought I would try and learn a faster language. I looked at C and C++, but the commands used seemed incomprehensible. It was then that I learnt about a new programming language called Python. Python was invented in the late 1980s by Guido van Rossum, a Dutch programmer who is otherwise known by the Python community as Benevolent Dictator for Life. The main features of Python are that it's simple and powerful, and much of the syntax is quite similar to BASIC. The fact that the language is named after Monty Python, along with the fact that it's open source, also makes the language quite appealing. I enrolled in a free online course with the Massachusetts Institute of Technology under their EDX program, and 6 months later I had a good understanding of Python and a certificate from MIT. Python is an interpreted language, but compilers are available, such as CPython, which can speed things up considerably. Even though it's an interpreted language, it still runs comparatively quickly. Furthermore, Python can be expanded by the use of add-on libraries written by the Python community. There are, for example, Python libraries to do image processing and implement extensions for Windows. So why should you be interested in learning Python? The answer is that the Raspberry Pi, that popular low-cost single-board computer from England, can run Python. Furthermore, it's possible to configure Linux so that your Python program will start up from boot. That gives you an Arduino-like functionality, but with a much more powerful processor and extended graphics capability. That's not to say that the Arduino is bad. For simple embedded applications, the Arduino uses less power, is smaller, and is quite appropriate. However, for higher-end applications, for example involving graphics or applications requiring more speed, the Raspberry Pi is the better choice. And for standalone applications requiring significant computational power, a standalone computer running on Linux or Windows is the better option. To get started with Python, you need to download the IDE, the Integrated Development Environment. It's called IDLE and is of course named after Eric Idle of Monty Python fame. And IDE is just a fancy name for a word processor with some added functionality. If you visit www.python.org, you can download Python for Linux, Windows or your Mac. You'll see mention of two versions of Python, version 2 and version 3. Version 2 is the old version, and version 3 is an updated version 2 with some slightly different commands. However, I prefer to use version 2 because it has better library support. Once you've installed Python, you'll see an icon on your desktop called IDLE. You can double-click on this to open the IDE. If you're using the Raspberry Pi with the Raspbian operating system, you'll find that Python comes pre-installed. However, I wouldn't recommend using the Raspberry Pi for program development because the operating system can run quite slowly at times in its graphical environment. You're better off installing Python on a standalone computer, developing the program there as far as you can, then transferring the program to your Pi to be finished and tested. Let's now open up IDLE and make a simple program to illustrate just how easy it is to program in Python. First, click on the IDLE icon. You're now in the IDE. The first thing to note is that the interpreter can function as a command line interpreter. In other words, you can give the interpreter commands and it will respond in real time. At this point, I should point out that making a computer program is much like making a recipe. A computer program consists of a series of commands that you give to the computer. Some commands immediately do one thing only. For example, they print a number to the screen. Other commands do things multiple times. For example, the while command will continue to execute a series of commands immediately under the while command and indented a few spaces in until a certain condition is met. And other commands are conditional. For example, the if command looks to see whether a particular statement is true or not, and if it is, it will execute a series of commands that are indented a number of spaces from the left and immediately under the if command. Let's now look at a simple program I found on the internet. Before executing the program, you first save it, File Save, and then hit F5. Let's now look at what the program did when I pressed F5. The first statement set the variable count to a value of 0. Next we have a while statement, and what happens here is that there are a series of commands which will continue to be executed over and over again so long as the statement immediately after the while command is true. In other words, for so long as the value of the variable count is less than 9, the computer will execute the indented commands. It first prints out the value of count, initially this is 0, and then increments the value of count by 1. The while statement now checks to see if count is less than 9, which it still is, and again prints out the value of count and again increments count by 2. As you can see, as it goes round and round, the value of count is increasing until finally it reaches 9. Eventually get to the point where count is incremented up to the value of 9. At this point, count is no longer less than 9, so the statement count is less than 9 is no longer true, and the computer exits the loop and continues executing the commands immediately following. The next and last command it encounters is simply a command to print the word goodbye on the screen. At this point, we know the computer has finished running the program. As you can see, the commands are plain English and simple to understand. A full Python tutorial can be found at www.tutorialspoint.com/python/. Once you have mastered the black art of Python programming, you can look around on the internet for add-on libraries which expand the functionality of Python and give your programs greater power. And if you're really brave, you can Google Python, Raspberry Pi, GPIO pins to find resources to teach you how to control the GPIO pins on the Raspberry Pi from Python. There's also great support for Python programming at www.raspberrypi.org/forums/. You can ask questions in the Python forum and get help with your programming problems.
Well, I'm going to have to take a look at Python.
Yeah, that's pretty cool. I had no idea it was named after Monty Python, though. I thought it would be cool if they would have named it. I know you know what I'm talking about.
Yeah, I wanted to learn
the nights.
Yeah, I actually do have a fully working program which will take images from the SOHO telescope and find comets, and it actually works. It's not perfect, but it's good enough to be a workable proposition. So. And it runs, well, reasonably quickly given the amount of computations that it has to do. If it was in C, it would run a little bit quicker, of course, but just shows you what you can do if you actually with a language like that.
Yeah, it's a powerful language. I know a lot of system administrators use it to maintain their servers and stuff too. You can do pretty much anything with it.
Yeah.
And although I skimmed over it very quickly, you heard mention of a language called Just Basic. If you're really into basic programming, I'd encourage people to check that out because that's quite a good free implementation of Basic for your Windows machine.
Will that run on the Raspberry Pi as well?
No. I think this one's purely for Windows, maybe Mac as well.
I think there is a basic interpreter for the Pi, though. I think it seemed like I had it on there when we first got them.
Okay, cool.
What was your, just quickly, what was your thoughts on line numbers? I always rather liked them, but a lot of people didn't, unfortunately.
I really hadn't thought about it.
Yeah, I didn't miss them when they were gone, but I didn't mind them when I had to use them either.
Yeah. Easier to find your place in a program, I guess, with them. But, most of your modern program environments will show you the line number down at the bottom anyway, if you just remember to look.
Yeah, but you don't have to do a go-to.
That's true. You can, though. You don't have to.
Yeah.
Well, we'll be back with more in just a moment. The new Heil Pro 7 headset was designed using technology Bob Heil learned from Paul Klipsch back in the early 70s. The ear cup is specially tuned for very low distortion with maximum voice articulation, providing the ultimate communication sound reproduction. The 2-inch thick gel foam ear pads provide extreme comfort for extended periods of operation and passive noise reduction to minus 26 dB, ideal for use in high ambient noise environments. The exclusive Heil phase reversal system allows you to acoustically move signals forward and creates a spatial widening of the sound field, making it easier to pull a weak signal from a pileup. The Pro 7 also includes a speaker balance control and the ability to interchange microphone elements. The Pro 7 comes with the Heil HC7 dynamic element featuring the Heil speech articulation response curve, and the Pro 7 IC has an electric element for low-gain ICOM radios. With color choices of black, red, blue, and pink, there's a Heil Pro 7 headset made just for you.
Gigaparts is the largest independent amateur radio dealer in the nation. Everything you need for ham radio, including books, DVDs, antennas, rope, coax, and tuners. Gigaparts has it all and is open Monday through Saturday. Call us toll-free at 866-535-4442. and our friendly staff will be happy to help you find the right products for nearly any project and budget. Online shopping made easy with real-time pricing and availability, and free shipping on most orders. Go to gigaparts.com and enter to win a free radio. Have a question? Click on Live Chat for a quick answer. Low prices? Huge selection. America's favorite ham radio store is Gigaparts.
Use the coupon code ALTV-HEIL at gigaparts.com by December the 31st, 2014, and you can save $10 off any color of Heil Pro 7 headsets. You know, Tommy, that was a pretty nice looking set of headphones.
Yeah, those are nice. I didn't know he had those. They must be brand new.
They are brand new. As a matter of fact, they shipped some in here for me to make that commercial with, and I had them for one day, and I had to ship them back because, they really haven't been released yet, and they had to scrape together parts to put some together for me to use for that.
Yeah.
Ship them right back. But I believe middle of this month, they're supposed to be out on the market.
Cool.
So, a nice set of headphones there. Well, I did a little playing with meters this time, watt meters, SWR meters and all. And let's just take a look at that. Let's talk a little bit about watt meters. In the early days of ham radio, we really didn't have watt meters, and amateurs would often use a light bulb to tune their rig up. The brighter the bulb, the higher the wattage. Eventually, we did get meters to measure forward and reflected power. Let's take a look at a few of them here. On the low end, this is a CB watt meter from the 1970s. It had scales for 10 watts and 100 watts and also measured VSWR. Now, there are some hams that use these as their watt meters for amateur use. I would be careful of that. These things are made to operate on the CB frequencies and may not necessarily be accurate on all the ham bands. But let's take a look at how you would use this watt meter. An RF watt meter will have an input and an output, and it's important that you observe that when you're connecting it. Transmitter goes on the input, and your antenna or dummy load goes on the output. Now, if I key a rig into this one, the rig is set for 100 watts. I'm on the 100 watt scale here. I see I've got approximately 80 watts according to this meter. Now, this is a CB meter, and I'm actually operating on 20 meters. So there could be some discrepancy there. Now, how would you check SWR with this? Well, you put your meter into the SWR position, and you also put the other switch into the forward position, and then you adjust the set level. You key up the transmitter, and you adjust the needle here until it's right at the end of the scale. Once you've done that, you flip the switch back to the reflected position, and there's your reflected power. A little over 1.1 to 1. A lot of meters use this method of calibration for SWR, and it could be a little bit different on some. For a number of years now, many HF transceivers have had a watt meter and SWR meter function built into them. This old TS450S has a watt meter, and you can see it says it's reading 100 watts of power here, and it has an SWR around 1.1. Now, you may have to go through some menu settings or some switch pushes to get to the correct scales. Here we have the transmit meter, and we can see that that cycles through between ALC and SWR. On this FT857D, there's still a meter where you can select between modulation, power, ALC, and SWR. It's just a bar graph and there's no scale, so it's just kind of a relative indicator more so than an actual meter you could make measurements with. Now, one thing that's going to be important, if you're trying to measure power, you're going to have to choose a mode on the rig that actually has a continuous carrier like AM or FM or perhaps RIDI. If you've got it on sideband, you'll only see power when you're modulating the rig. This IC7700 gives you a pretty good indication of exactly what you've got. You can see we've got a power out here of 50 watts on AM and almost no VSWR. I mentioned earlier about the CB watt meter maybe not being so great on HF. That's true of a lot of different watt meters. Different ones are made for different bands. This one is made for VHF and UHF, and I bought it at Radio Shack a number of years ago. You can still find practically this same meter available today with different names on it. If I key it up on 2 meters here, the rig's set to 50 watts. I'm on the 60 watt scale, and we can see I'm showing 50 watts up here. To measure SWR, I just flip the switch here, and we can see this dummy load only has a tiny bit of SWR to it. So for VHF and UHF, you'll probably need a different meter than you would use for HF. Some meters even come with different slugs to change the frequency bands. Some HF antenna tuners like this MFJ come with a watt meter built in. The rig is putting out 50 watts, and we can see it says it's a little above 50 here. Now I'm on AM, and the reflected power is just above 3 watts. To measure the SWR, you look at where these 2 meters cross each other on the red line, and we can see we're just above 1.5 to 1 VSWR. There's also a switch on here to measure peak or average. There is a difference. Right now it's on average. If we put it on peak, we're not really going to see a change here with just a steady AM carrier. However, when we start modulating it, we'll notice a difference. On peak, you can see it's kind of rounding out here to around 50 watts. If we go back to average, we can see that there's more deflection in the meter. When we use single sideband modulation, we can see that there's only carrier with the voice modulation. And we can see here on average, it's peaking up close to 100 watts on some peaks there. It's moving a lot, so it's hard to tell exactly what's going on. If we put it on peak, we can see it kind of smooths it out. So you can see now easily that we're peaking around 100 watts. The additional dampening on here makes it a little easier to see where our modulation peaks are. As hams, we're really interested in peak power because our maximum power output is 1500 watts peak to peak. Here's a little better meter than the one built into the tuner. This is another MFJ model. It's a true peak reading meter that's going to show us our true peaks. We have the same average or peak button here, but you're going to find that it operates a little different. We've got it on the 300 watt scale, average, and I'm transmitting single sideband. Now, this is a IC7700. It's a 200 watt rig. You'll see we're getting readers similar to what we had on the tuner. However, if we flip and peak here, we'll find out that we've got a lot more power than that. The meter's reading a little over 250 watts peak to peak. Now, I'm not sure about the calibration there, and another thing to keep in mind is the accuracy of your watt meter is going to be determined by the load, and it should have a good 50 ohm purely resistive load. But with the true peak reading meter, we can get a much better idea of actually how much power we are putting out. Now let's step things up a few notches with the Applied Engineering Science DWM2 digital reflectometer. It was carefully designed and aligned to NIST traceable standards. That's the National Institute of Standards and Technology. They maintain the standards by which all precision watt meters are calibrated against. This meter is capable of accurately measuring power in VSWR from less than 1 watt up to 2 kilowatts from 1 to 60 megahertz without any slugs or exchanging directional couplers. And there's a new directional coupler that'll be available soon that covers 50 megahertz up to 1 gigahertz with a 1 kilowatt continuous duty. This watt meter can even accurately respond to a single DIT at 60 words per minute. The DWM2 is very useful in environments where peak to average power ratios can be extreme, as well as in pulse power measurements. It's excellent for measuring AM, FM, sideband, CW, RIDI, and single sideband transmissions, as well as digital like PSK 31, 16, 64, and 256 QAM signals. This meter is also ideal for industrial, scientific, and medical applications where peak and average power measurements are important. It comes as 2 components. The DWM2 reflectometer mainframe has a nice resistive touchscreen interface, and there's no switches on it to wear out or get dirty over time. This meter can measure up to 2,000 watts continuously from 1 to 30 megahertz and 1,000 watts continuously from 30 to 60 megahertz. However, the instantaneous peak power can be measured as high as 4,000 watts on the full range from 1 to 60 megahertz. The other half of the instrument is a DC-1 RF directional coupler that you insert in the transmission path, and this means you can have the directional coupler mounted in the most appropriate place near your gear, and the mainframe can be positioned in a convenient operating location. Also, since you can have up to 4 directional couplers with this system, that means this one meter can be used with several different transmitters and antennas without worrying about changing patch cables or complicated switching arrangements. When you turn on the unit, it goes through a boot-up process. You're allowed to set the brightness of the display as well as configure the directional couplers. The setup screen allows us to adjust each of the 4 couplers to their specific calibration. Each coupler has a label on it that gives the values which should be entered in here. The unit gives you a variety of measurements all simultaneously. There's an analog forward power meter. There's a bar graph VSWR meter, an SWR alarm indicator if you go greater than 3 to 1 SWR. There's also an indicator here that tells us the analog power is within range. We've got a digital forward average power readout, a digital reflected power readout, a digital peak power readout, and a digital SWR readout. There's also a range select switch here so that we can select to 20 watts full scale, 200 watts full scale, or 2000 watts full scale. And a mode select here. With the tune mode you can choose that disables the SWR alarm while you're tuning. Also, tune mode increases the display refresh rate by speeding it up to an analog-like response so you can tune an amplifier or a tuner. It's about 10 times the speed of normal operating mode. At the top here is a port select switch where you can select between one of 4 directional couplers. Now let's do a little testing. So let's choose the 200 watt range here and see what power output we have. Going by the meters, we have 19 watts of forward power, and I think this rig is limited to probably 20 watts on AM and a peak power of 21.9. If we modulate the unit, we'll see that the readings do change a little bit. We'll get a peak power up to 41.4 watts. and our reflected power on this dummy load is 1.16 to 1. We can see it's barely indicating here on the VSWR meter, and if we look up here on the analog meter, we can see we're just under 20 watts there, which coincides with the forward power digital display. Now let's switch it over to sideband and have a look. When we begin modulating the rig here, we see that the forward power is really not going that high. There's 25 watts. We can also see on the analog range over here, it looks like it's less than 50 watts. However, if we look down here at our peak power, we can see that we are doing 100 watts and greater. Now let's add a little bit of power to the equation. The analog watt meter on my tuner only shows I'm doing 300 or 400 watts. However, if I look here at the peak power on the digital reflectometer, I find out that I'm doing in excess of 500 watts, which is about what I would expect. So if you're looking for a nice looking meter that's easy to operate and gives you a lot of measurements all at once, then it's going to be hard to beat this Applied Engineering Science DWM2. Well, I hope you've enjoyed our look around watt meters and perhaps learned a little something. There's a lot of different models out there, and with a little research, you can find one right for your application. You know, watt meters, that's just kind of one of those things that you need. A lot of HF rigs today have a watt meter and SWR meter built into them, but not so with VHF and UHF rigs.
Right. I don't know why they don't put those in there, but I don't think it really had that much cost to it. But I'm almost embarrassed to say, out of all the meters you showed there, you remember the little Radio Shack?
Yeah.
That's actually the one I still use.
Oh, yeah. Well, for VHF and UHF.
Right.
Yeah.
Yeah, for HF I use my one in my tuner.
Yeah.
George, I've got a question here, more for some of the beginners out there. Let's say you've got your nice brand new shiny rig back from Gigaparts, and you've set up an antenna. Where should you measure your SWR? At the antenna or at the rig?
That's a trick question, Peter, because you want the rig to see minimum reflected power, so you'd want to measure there for that. However, you want the antenna to be 50 ohms, so you should measure it there to see exactly what the antenna is. So I guess ideally you would measure it at the antenna, get the antenna correct, then put your coax in line and then measure it again at the rig.
Yeah, I'd agree with that. I think that just because you're seeing a low SWR with your antenna tuner or whatever at the rig doesn't necessarily mean that your antenna is radiating efficiently. There could be a problem with your coax. So I think it's good to measure both. Yeah.
And ideally also the tuner should be at the bottom of the antenna, not next to the rig.
Mm-hmm.
Yeah. And one other quick tip, just for those that are new to the hobby, when you're using your SWR meter, for the first time with your rig, make sure you turn the power output of the rig right down, and typically don't use single sideband, use something with a carrier like AM, and just measure at low power first, then once you've tuned your antenna, then you can crank up the power.
Yeah, I mentioned using AM, FM, or RIDI, but you could actually use CW2 on some rigs. On mine, most of them, if you hit push to talk while you're on CW, it doesn't do anything. You got to connect a key into the rear of the rig. So anyway, let's get on into some emails here. This one comes from Gary, the winner of our AmateurLogic t-shirt. You remember in our our 9th anniversary contest? He's going to take a picture of himself and send it to us, and because we want to see that. But he's been traveling, so he hasn't been able to do that. And by the way, if you go to the AmateurLogic.Spreadshirt.com and pick up a t-shirt on there, send us a picture of you wearing your shirt, or you could actually, I don't know, I guess you could put it on a hot chick and send a picture of that too, but we'll put it on the show here for you and just see who's wearing the shirts these days. But Gary said, I'm demoing this thing, AT&T Remote Mobility Zone. It's a self-contained comm trailer with a private cell site for pre-designated private whitelisted users, Wi-Fi with satellite backhaul, a 9 kW generator, a 50-foot mast for antennas, satellite audio acquirer, and you can get service where no service exists, or supplement the normal cell network where it may be too congested because of special events or services, outages, or disasters, one thing or another. And they sell those to customers, and then they subscribe to a monthly service, and it becomes their private cell site, and his company manages the frequency coordinating when they use it. He said that's the latest toy that he's been messing with. Wouldn't you like to have one of those?
Yeah, that's pretty awesome right there.
That would be nice at field day, wouldn't it?
Yeah, no kidding.
But pretty neat there. What have you got over there, Tommy?
Yeah, I've got one more. Actually, this is kind of part of a thread. It was so long. This one's actually from Michael, AB7YZ. And Michael emailed me about having some trouble setting up his DV Mega. He bought the kit from Gigaparts, which they still have some of those in stock. I looked, and they got some of them back. But anyway, he was having trouble. He would get a message on his repeater software that said that it was an invalid header every time he would key up. So I had him go back and change the offset in the radio to make it look like it's a repeater, but have a 0 offset frequency on it. So it actually transmitted and received on the same frequency. But anyway, he emailed back and said that he programmed the DV Mega as a repeater suggested with the duplex and 0 offset. First time microchunked, it reports not linked. The second time, it responds that it's linking, but it never actually links. So I actually had him re-download the image and start over with the steps again, which I had a similar problem, and I did it, follow the steps to the letter. He programmed it and everything's cool. So if you have trouble setting that up, just get the image, start over again, and it for some reason almost works the second time every time. I've had 3 or 4 people email me.
Really?
Gave them the same suggestion, which worked every time.
Cool. For years, hams have relied on the world's most popular antenna analyzer, the MFJ259B. That compact battery-powered RF impedance analyzer combined 4 basic circuits, a 1.8 through 170 MHz variable frequency oscillator, a frequency counter, a 50-ohm RF bridge, and an 8-bit microcontroller. Now the MFJ259 has been updated to the new MFJ259C. All the same great functions present in the 259B with an expanded frequency range. The MFJ259C covers all frequencies from 530 kHz to 230 MHz. If you need to measure UHF, the MFJ269C adds 415 to 470 MHz. And MFJ's got 2 new graphic antenna analyzers as well. You get the big picture every time with MFJ225's built-in backlighted 3-inch LCD graphic display. Make fine circuit adjustments using full-screen, easy-to-view SWR bar graph, capture vivid swept displays for SWR, impedance, return loss, phase angle, and more. Operation is simple. Adjust the center frequency, tuning step, and sweep width instantly while viewing your plot, literally shaping it before your eyes. The MFJ225 tunes continuously from 1.5 to 179.9 MHz with rock-solid stability and no gaps. The new MFJ223 breaks the size barrier for RF analyzers by delivering user-friendly convenience, top-notch accuracy, and a vivid TFT multicolor display in an ultra-compact package. Use the single-frequency mode to view standing wave ratio, resistance, reactance, and local interference level simultaneously on a high-resolution analog bar graph display. Use the scan frequency mode to graphically plot SWR, resistance, reactance, and impedance. All 4 plots are captured as a sequence of sharply defined color graphics. No one knows more about antenna analyzers than MFJ. Visit MFJenterprises.com today. Nice antenna analyzers.
Yeah, I really like those new graphical ones they've got.
Yeah, that's my favorite one. Not the color one, but the other one.
Yeah, the one right before the last one. Yeah.
If I ever use the color one much, so I might think it was my favorite.
Maybe.
Really didn't play with it much. Well, what have you got for us this month?
We had some viewers, like I mentioned a few moments ago, ask about setting up an iGate for old school APRS. We're going to do something this month on Amateur Logic that I guess we probably haven't really done very much of before, and that's APRS. Not DPRS through D-Star, but regular old school APRS. And we had someone ask how to set up an iGate. Well, an iGate is basically an APRS station that receives packets and will route them through to the internet, to the APRS network, so you can find yourself on APRS.FI, or you can send messages to other people that'll route through the internet, things like that. We're going to go kind of low budget on it this time, which is my favorite way to go, and we're going to use a Raspberry Pi for the computer. And we've got this TNC Pi that George actually built on Ham Nation, and it's been sitting on the shelf, and we're going to use it. It's a pretty nice little board. It matches up perfectly with the GPIO pins on the Pi. It costs around in the $40-ish range for the kit. And while he put this one together, I did look over the build instructions, and it looks pretty easy to do. I'm sure I could do this myself without too much trouble. To mount the board onto the Pi, it just plugs right onto the GPIO pins. If you look at it pretty close, you'll see there's a little clearance there. And the reason for that is the solder connections on the bottom of the serial port that hooks up to the TNC Pi are right above the USB ports on the Pi itself. So there's a piece of sticky foam in the middle to insulate it so you don't get a shortage condition there. To hook this up to the radio, it only takes 4 wires. You've got the input audio, the output audio, push to talk, and a ground. I decided to use my old 857D for this. It's just kind of sitting there. And I'm going to use the data port on the back since it's already got everything I need in one. So I have a PS2 keyboard extender cable and a DB9 that's hooked up to it, because this PS2 cable actually fits the back of my rig perfectly. You need to look in the documentation for your radio to see what the wiring diagram is for it. I've taken the liberty to go ahead and fix my Raspberry Pi. I've got the Wi-Fi dongle already in here, and I've got an SD card with the latest Raspbian on it. I've gone ahead and changed my password, installed VNC so I could demo for you, and it's all set up so my network is ready to go. So I'm just going to go ahead and plug it up, and we'll power it up and get started. The software we're going to use is called Zaster, and it's a GUI application that'll show you a map and the representation of all the APRS stations in your area. It also has some pretty neat networking capabilities built in that you can communicate with the modem over the internet, GPS, and various things. Speaking of GPS, I don't have one that I'm going to hook up today. I'm going to just put my coordinates in here since the thing's at my house and it won't be moving, but you can hook up a GPS to it if you like. First thing we need to do is install the software. So let's bring up a terminal client. Sudo apt get install Xastir, Xastir. While that's installing, you don't have to run this as an iGate. You can just have a standalone APRS station. We've got a digipeater close to my house, which you'll see in a few moments when we get set up. And there's some people in the area. Hopefully they'll be using APRS. And you'll see that it gets routed from their place to the digipeater to an iGate that's a good bit south of me. And when my station comes on, it'll know that I'm closer, and it'll actually start routing that traffic to my iGate here instead of the other one. If you don't have a dedicated transceiver you want to hook up to it and you want to put an iGate on, by all means use an old scanner, whatever you got that'll pick up the 144.39 frequency, and it'll actually work for you as well. It'll take the traffic, route it to the internet. Unfortunately, it won't send anything back, but that's okay for an iGate. There's one thing we're going to need to do before we run the Xastir software. There's a line in the boot config file, it's actually a command line.txt file, that causes the system to use the serial port on the Pi. We need to remove that reference so we have access to the serial port to communicate back and forth with the modem. So let's do that. I'll go cd boot and sudo nano -w cmdline.txt, and there's the line, and it's this console right here. According to the documentation, there are two pieces of data you need to remove from here, but I'm only finding one in this latest version of Raspi, and I just downloaded it. It's a brand new version, actually from September. It was in the older one that I had when I was kind of looking around, but apparently they must have removed it. So we just need to remove from this 115.200 up to console, like that. Control X, Y to save, hit enter. We also need to change one setting in the init tab, and that's in the WAC etc folder. So let's go cd WAC etc, and I'll just use the up arrow, and we'll change this to INIT-TAB, and down near the bottom there's a line that we need to comment out. Spawn the Raspberry Pi serial line, just put a £sign in front of that, and that will keep it from executing. Control X, Y, and enter. After we reboot, our serial port will be free, and we can communicate with the modem from the Pi. Alright, that's installed. Let's run it and configure the software. We'll find our new program under the Other menu, and it should be down here, Zaster, right there. To connect to the database over the internet, you'll need a password, and basically there's a utility here that we'll run that'll take care of that for us. Okay, so let's put our call sign in, and I'm going to do -10 SSID. I looked it up, and that's one that's typically used for an iGate, so I'm going to go with that. Since I don't have a GPS, I just so happen to have my coordinates written down here. I think I'll change this comment to say Zaster iGate, just for fun. And the rest of it, I believe we'll just leave alone. Let's maximize that so we can see it a little better. Now this is a vector map that we're looking at, so it scales. It's not the best detail, but it's good enough for me. There's some other ones that you can download. I haven't really played around with that. So let's go ahead and zoom in a little bit so we can see the map a little better. We should see ourselves. There I am right there. Let's go ahead and finish the configuration. We'll do File, Configure, Defaults, and we're going to have a fixed station. I want to allow RF internet traffic to and from my station here. If you don't want to be an iGate, make sure that this Disable All iGate Traffic box is checked here, and then you'll be just a regular APRS station. I'm going to go ahead and click Save Config. Now that we've configured the default stuff, let's go ahead and add the interface that'll communicate with the TNC modem and the one that'll actually communicate with the internet. To do that, we'll go to Interface, Interface Control, and we'll add. And this one's going to be Serial KISS TNC. The TNC port is going to be WAC DEV TTY AMA 0, just like that. The punctuation and capitalization count. The port is going to be 19,200, since that's the only one that the device actually supports. And here we want to enable our internet traffic as well. So I set mine there. Again, if you don't want an iGate, turn that one, put it back to disable. And I've changed that to KISS mode on startup. KISS is the mode of the modem that the software knows how to communicate. So I'm going to go ahead and change that. Now, we can enable that and start seeing APRS, except we need to turn the radio on. There's some weirdness that happens on this program, and you'll see that the buttons are gone at the bottom here. To get it back, just close it and go back to interface and interface control again, and it's back. So we can actually start that port, and now it's communicating. When a packet comes across APRS on the radio, it's going to come through the modem here. It's going to decode it, and the software is going to display it on the screen. While we're waiting on someone to send the packet across, APRS is a little quiet in my area. I'm going to go ahead and send mine. So I'll go to interface, transmit now, and you can see it transmitted. So if we go to APRS.FI, you can see right here, there's my N5ZNO10, my Zaster Igate, and you can see, well, this is actually the time that I'm shooting this video, so this is correct. Let's go ahead and add the other interface so we can have the internet traffic as well. When you see that come up, you're going to see this thing go crazy. That's why I was kind of waiting. There's somebody else on there. Let's add that internet port. Add, internet server, add, and allow transmitting is on. All these are the defaults. If you notice, we need a passcode. When we installed Zaster, it installed a utility to generate a passcode, and we'll run it. All we need to do is bring up the terminal again, run call pass, put your call sign in there, and it'll give you a number back. Plug the number in right here. And I did it yesterday. I'm not going to show you my number. As close as we are, I'm not going to show you my password. So I'm going to go ahead and type it in. And that port is down. So let's go ahead and start that one too. Look at all those stations popping up over the internet. These are showing all the stations that have reported in over a certain time frame. Let's check on APRS.FI and see if we've actually started routing any data through yet. You would know it'd be pretty quiet out there right now. Okay, it's been a few minutes. I'm starting to hear some traffic. Let's see if we routed any to our iGate now. I can see on my map here that we've got quite a few more stations showing up. Let's bring up our browser. And there's my station. There's the digipeater I told you that's close to my house. And let's see. He has not transmitted. Here's one way down here. And if you'll look at that one, his path went up to the digipeater right there. If you look at his path, you can see it went from his station, it hit the digi, and then it went to my station. You got to admit, that is a really easy and relatively inexpensive way to get an APRS station on the air, much less an iGate at that. Anyway, 73, I hope you enjoyed it, and we'll catch you next time.
That was pretty inexpensive. Tommy, how much did that cost you?
Well, I had a Raspberry Pi laying there, and I stole the modem from you, so it didn't really cost me much of anything.
Yeah. Looked like fun. You know, I hadn't played with that thing in a long time, so I was glad to see you do something with it.
It's neat stuff. I wish there was more traffic around here on it. Some areas, you know, it's pretty busy. It's just really not here.
Yeah.
But it's cool. If you want to get an iGate on the air, you know, that's a pretty cheap way to do it. And you don't have to have a transceiver. You can just use a scanner or a receiver and actually have a, you know, one way. So.
Yeah.
Do you have a local BBS in your area in Jackson?
Not anymore.
No.
All that stuff's pretty much dead around here.
Yeah, I always enjoyed logging into a BBS and seeing the headers coming over from NASA. They send like regular messages, just updates of technological things that are happening, and it gets routed through the APRS network, which is pretty good.
Oh, yeah?
Yeah.
Yeah, just search on space.
Yeah.
Yeah. We had Packet back in, well, in the 90s. We used to do a fair amount of it.
Pretty good bit. It was so much fun. I really hate it went away, but I guess the internet and cell phones and texting must have killed that.
Yeah, and 2400 baud, you know, or 1200, whatever we were running.
But it's plenty fast enough to send ASCII messages.
Yeah, yeah. And we finally got 9600 on. Some people got that. I never
did do that. That was a little bit rich for my blood at the time.
Yeah. Well, we'll be back in a moment with a little more entertainment for you. Got a license or just upgraded? Get on HF with ICOM. Check out the IC7200, IC7410, and IC7100. Each feature ICOM's signature DSP technology. The IC7200 is an entry-level radio that's packed with quality features, including AGC loop management, built-in digital filters, twin-pass band tuning, and manual notch filter. You'll also get digital noise reduction and noise blanker in this high-stability transmitter, and you can take this rig out of the shack. It's built military tough with waterproof buttons and knobs. The IC7410 is a high-performance radio for everyday HF communications. Features include fast digital signal processing, double conversion super heterodyne system, built-in 15 kHz first IF filter with optional 3 kHz and 6 kHz first IF filters. This promotes enhanced operation on CW and single sideband modes. The IC7100 employs multiband and all-mode digital operation right at your fingertips. Features include touchscreen and angled control head for optimal viewing, 32-bit floating point DSP for powerful HF operation, and optional RSBA1 IP remote control software. Look to the future of HF with this D-Star radio. So whether you've just got your license or just upgraded, get on HF with ICOM.
Well, let's get on back into the emails here. Peter, you've got one more, don't you?
Yeah, I've got one more, and it's a doozy. This email's from somebody called RivPat77. They didn't leave a name or a call sign, but it's an interesting question. He asks, or he says, that he has a G5RV with a centre-fed 20-metre dipole. Now, I'm not clear as to whether he's got them both connected at the same time, because G5RV is different from a 20-metre dipole. But he says that he noticed that if he tries to tune the rig before the sun comes up, it won't tune. After the sun comes up, it tunes on all bands easily. Any suggestions? I can only think that there's some kind of temperature-dependent, what would you call it? Poor connection along the along his coax somewhere. What do you guys think?
Yeah, I think two things. One, it could be temperature dependent. You know, copper expands and contracts with temperature, and maybe something is moving. There's a bad connection, and you know, as the copper expands and contracts, it's making and breaking it. I mean, I've seen this on broadcast stations before, where where copper did that. And the other thing I think is maybe he's getting a little moisture in a connector or somewhere, and as the sun comes up, it dries it out.
Well, that could very well be.
Yeah.
Yeah.
So that.
Yeah, but thanks for the email. Yeah.
Yeah, and I've got one final email here, and this one comes from a guy who's in the chat room right now. It's Arnie K5ARN. You remember Arnie?
Oh yeah, man.
Our buddy from up at Columbus.
Arnie's the only one on the whole planet that's got the I'm a fan of AmateurLogic badge.
I think maybe somebody else got one, but I know he's the one who started it.
Yeah.
Yeah. But anyway, he says, congratulations on 9 years. It's an outstanding accomplishment for you and Tommy and Peter and Jimmy in the beginning. And it says it's helped him so much to become a ham after retired. He's watched for 6.5 years while he's cruising to Sweden at one time. Wait a minute, let me read that again. He watched 6.5 years of the show while cruising to Sweden one time. He says he learned so much. Boy, 6.5 years, that was a long cruise, wasn't it?
It's a long time.
Yeah. He says, what I like is the laid-back Southern style you have. It's so friendly and homey, but still very informative. Please do not lose that style. I don't think we're at risk of losing it. But yesterday's live show, and I guess this is the one, maybe it was Pacificon. Maybe it was
Must have been the one we shot last weekend.
Yeah, was a test for you, but considering this, there was not one harsh word or negative comment in the chat room. Everybody understood and had a good time. Yeah, and that's when we had so many problems streaming a couple of episodes back, I think. He says, after the show, we did some searching on the net and stumbled across this. And he said, this is a trinket from Adafruit. Maybe this would work in that antenna project I was working on, the servo antenna switcher. And it's not very expensive. And yeah, it probably would work. But, I just wanted to build something myself, so I'm not going that route. But he also sent a link to this, also from Adafruit, 5-volt bucking regulator. It'll take a range of voltage here right above 5 volts, step it down to 5 volts, and it's highly efficient, so you don't lose all the power that you lose in a normal linear, like a 7805 chip or something like that. Remember that Raspberry Pi power supply I built that was real efficient? Mm-hmm. It was pretty similar to that, but that was a little bit pricey right there. What is it, $14.95?
Yeah, $14.95. But I'd like to have one that I can use 6-volt batteries. I ended up with several 6-volt batteries, and I'd like to step them down to 5 volts to use them.
Yeah. Well, yeah, that would probably work good for that. Let's see. Well, thanks for that, Arnie, and thanks for watching. 6.5 years worth of AmateurLogic all at one time could be damaging to your health. We assume no responsibility.
He made it through it okay because he's in the chat room now.
Yeah. Oh, yeah.
So congrats on that feed alone.
I calculate that at 1 hour per episode, that would be about 78 hours solid viewing.
And most of them are an hour and 10 minutes or more.
Oh, yeah. Yeah. They're rarely exactly an hour anymore.
Yeah.
Usually a lot longer. Well, he was asking about the trinket, and I said I wanted to build my own. Here is my boards. I just got these back from Express PCB. This is going to be for my Arduino antenna switcher project. We looked at that, I guess a couple of months back now. But anyway, I showed you the schematic on it. Here it is to a printed circuit board that just came in this week, and I haven't tested it yet. I hadn't put any parts on it, but we'll be looking more at this in the future. And it's it's got a little proto area, so it's not strictly just for that one project.
So that's 2 boards in one, right?
Yeah, this is actually 2 boards. If you rip it down the middle here.
Put it right behind Peter.
Yeah, right behind Peter. If you rip it down the middle, you'll get 2 Arduinos on this one board. And I had to buy 3 boards was a quantity, so I'll get 6 Arduinos out of that.
Cool. That's a nice looking board.
Yeah, it is a nice looking board.
Yeah, I'd be curious to see after you get it stuffed and everything.
Yeah, I didn't buy the solder mask. That was going to be like an extra $25 to get the solder mask and get the legends and all printed on it. So
those are really tight little traces. You'd have had a heck of a time drawing those out and doing them yourself.
Yeah, I couldn't have done that with a Sharpie, could I?
No, I don't think so.
And one final, and this is not an email, this is a mail. Bruce N1 EBQ, he's the guy, he won a Chameleon MCOM antenna that I gave away over on Ham Nation in the Smoke and Solder segment. And he says he's going to have a lot of fun playing with that, and he'll let us know how it works out for him.
Cool.
But to show his appreciation for the hard work that we do, that benefits all the viewers, he's enclosed a small gift for me and for Tommy. Yeah.
Tony from Dayton.
Yeah. And he says, on AmateurLogic episode 69, Peter showed us a nifty little component tester that I have enjoyed, and I hope you guys will too. Probably would never have discovered this device if it weren't for your show, and it's just the kind of thing that makes AmateurLogic and Ham Nation fantastic resources for all hams. You make it entertaining as well as informative, and I hope that you'll continue to do so for some time to come. Well, thanks, Bruce, and yeah, Peter, we got one of your little component testers. Well, we actually got 2, one for each of us.
Yeah. Thanks a lot, Bruce. Really appreciate that. Very, very nice.
I'm hesitant to take credit for showing you the tester. Originally, I saw it on one of Julian Eilett's videos on YouTube. It's ILETT, and that's where I learned about it from. But I'm happy to share the knowledge. It's quite a good little device.
Oh, yeah, very nice little device. Couple other things here we want to talk about. Christmas is coming up soon. And now's a perfect opportunity to get your order in over at AmateurLogic.Spreadshirt.com. There's a special going on now. It may not be still going on by the time you watch this, depending on when you watch.
No, but there's actually another one coming up. I'll post there. There'll be several coming up between now and Christmas. I try not to put too many out there, but I just don't want to flood everybody with them. But there are a couple of good specials coming up, and when the really good ones come, I post them over in the usual social media.
Yeah, here's where you can get your AmateurLogic t-shirts, your polo shirts, your caps, jackets, all your AmateurLogic swag. Go over there and check it out. You know, you might see something on there that you just gotta have, and if you do get something from here, and I know a lot of you have, send us a picture of yourself wearing it, and we'll put it on the show.
It'd be the best looking one at Thanksgiving or at a Christmas party.
Yeah, exactly.
Tommy, George, when you were in Dayton earlier this year, were there many people wearing the T-shirts or the swag?
We saw some.
There were some.
Yeah.
Not as many as I would have liked to seen.
No.
But there were some that had them.
Yeah. You know, a lot of the events we go to, we see them. I did not see any at Pacificon, and, you know, as I mentioned, that's a shame because, you know, we're going to give a grand prize to the first one I
missed
saw.
out.
Yeah.
I bet they'll have them next year.
No, yeah, I bet they will. And I did see them in Oregon at CPAC, remember? I talked to those guys.
Yeah, they're out there. I'd like to see more out there. Represent, kind of spread the word, AmateurLogic.
Yeah. And another question here we've got for you. Our friends that do the D-Star Net over on Ham Nation asked, would we be interested in doing a D-Star Net on AmateurLogic? And if you would, send us an email, let us know, you know, if that's something you'd be interested in.
Yeah, it'd be nice if we get enough interest in it. We could start one of those up.
Yep. And, you know, so let us know. We tried it, a long time ago, and we really just weren't having that many D-Star visitors. So we kind of dropped it. But, hey, if you think it's something you want, we've done a lot of D-Star things here lately. So maybe, you know, maybe there's a better crowd out there now.
Well, I've actually had a few people ask me why we didn't have a D-Star Net. So I think there's a little interest. We'll, if you guys are interested in it, let us know. And if you are, if there's enough interest, we'll get one put together.
Yeah. And, well, we just want to mention a couple of things here before we go. The AmateurLogic Echolink Net is going to be when?
November the 17th.
And that's going to be at 8:30 Central Standard Time, or?
Yeah, 0230 UTC. I have to look at just cheap. I'm actually pretty impressed that you got the slide up there this time, because a lot of times we have last month's on there.
Well, actually, I did this one, and I looked at it just before you got here, and it said October 17th.
Oh, there you
go. I did go in and change it, and I added UTC to it as well, and I made it Central Standard Time instead of Central Daylight Time.
So I'm a little, you see why I'm a little gun-shy just to read it.
Yeah, I do. Also, you know, we've got our social networks that have really been growing. We got the Facebook group. That's facebook.com/groups/AmateurLogic.TV. And, you know, we're almost at 3,000 now.
Yeah, I saw that. I added a few today, so I think we're maybe 5 people short.
Yeah. So get a few more in there. We'll hit 3,000 on the AmateurLogic group. I don't know what we're going to do when we get there.
Yeah, you know, if every morning I wake up, I check all that stuff on my iPad before I get ready for work. And there's always 2 or 3 on there, but it's usually really hot chicks. But to have guys' names on them for some reason, and they have brand new Facebook accounts, never had a friend, anything. So if we kept adding those, we'd probably be up to 4,000 by now.
Yeah, and everybody would have plenty of sunglasses and designer bags too, because that's what they usually post.
Every now and then one slips through like that.
Yeah, but we try to keep the spam to a minimum by carefully vetting all of our group members. So that means we've vetted almost 3,000 now for the group. We've also got a good group going over at Google Plus.
Yeah, that's a good community. We got probably 1,600 people over there, and a lot of fun stuff over there. That's where Mike posts the Photoshop pictures a lot, and so check that out if you haven't been there.
And you can follow us on Twitter at AmateurLogic. And I guess that's about all I've got here in my stack of papers. Y'all got any
Not
ideas?
quite. Not quite. If just a quick addition, you might, for those of you who've been on the Facebook site, you might have seen that in the last week I was interviewed on Satellite Nation. So I just want to give a quick shout out for Satellite Nation, and for Mike and the other host whose name just escapes me at the moment. I apologise. Go check that out.
Yeah, and I listened to it this week. It was real interesting. You know, I did one a few weeks ago with him. I think you're going to be doing it.
Yeah, I'm scheduled for not this week, but the following week.
And I think the link is satelliteguys.us. Does that sound right, Peter?
I believe that's right.
Yeah.
Just 1 second, and we'll check. It's satelliteguys.us.
Yeah, it's an audio podcast, and I think they stream that over some subcarrier on the satellite as well.
Oh, I didn't know that.
I think they did. I'm not positive about that now, but yeah, a great group of guys there, and they talk about more than just satellites. So.
Oh yeah, it's an interesting show.
Yeah.
It
Well,
was a real honour just to be asked. Why anybody would want to listen to me rabbit on, I've no idea, but there you go.
yeah. Well, we hope everybody gets plenty of turkey coming up here later this month.
Oh yeah, I guess this is it until the Christmas show.
Yeah. Yep, I think you're right. Unless we come up with something, a bonus episode in between, I don't know if we will.
Yeah, you never really know about that.
Never really know. You just have to check around and find out. So I guess that's going to do it. So to everybody, happy Turkey Day.
Yep, happy Turkey Day 73.
Happy Turkey Day, 73s.
Well, what do you got for us this month? Do you remember?
Yeah, I do. But you caught me off guard.
What's he demoing? Well, let me see if I can hit the right button here. No, apparently I can't. Well,
That's a deep subject.
that is a deep subject.
Yeah.
I'm glad I brought it up.
Okay.
Yeah, I didn't buy the solder mask. That was going to be like an extra $2,500 for that. No, not $2,500. An extra $2,500.
Whoa. Here.
Yeah.
Oh.